the audio is just a little bit higher fidelity. Can you see my screen?
I can see your screen.
Okay. And the way I do this generally is I have a drawing tablet here where I can write a squared plus b squared equals c squared and draw the right triangle. And so it works much like an in-person session. And the advantage of using the GoToMeeting software as opposed to the Varsity Tutor is Varsity Tutor doesn't show exactly what you write. It tries to interpret it and uses some sort of a interpretation algorithm to see whether you wrote A or B or C. Whereas this program shows exactly what I write. Okay? Which is much easier for tutoring math, because a lot of times what you write is hard to do. And I am recording this, and we'll make available to you a copy of it, if that is helpful.
Okay, great.
Let's take a look at some of these problems.
All right, 1 second. Let me just get out a pen. Okay, I'm all set.
All right. I certainly know a few of these. Is X a member of the set X, comma, Y, comma, Z?
Okay, let's see. So the first one, so X is it's saying X is sum of X, Y, and Z. Is that what it's stating?
Well, I think that, like I said, set theory is not the part of the Common Core of pre-calc. So I'm not super up on set theory, and I'm not going to be able to help you with any of these last 5. But I believe this is true. In other words, what this is saying is that X is a member of this set, X, Y, Z. And yes, it is.
Oh, X is a member.
Right. I think that's what that means. How about the second one?
-4.
Well, is that true or false? Is -2 to the 4th power equal to 16?
False.
Correct, because there's no parentheses. In other words, if the problem was the following, if it was -2 to the 4th power, that would be true. Because you would take whatever's in the parentheses to the 4th power. And if you took -2 times itself 4 times, you would get a positive 16. But when it's stated like this, without parentheses, then the 4 only applies to the 2, and so that actually becomes -16. So the parentheses are paramount.
Right. So it would have to be.
So this would be false. It's not equal to 16.
It would have to be -2 within the bracket.
Yes, within parentheses. In other words, the negative sign would have to be part of what was being taken to the 4th power. And without the parentheses, it's not. In other words, whenever you see an exponent, it only applies to what is below it or what is below it in parentheses.
I see.
Okay? Now, the next 5 questions, I really don't have any idea on. I don't know what they're talking about.
I have those symbols in my book somewhere.
Okay.
The actual symbols.
All right. I'll leave those to you. Most of the rest of the test I can help you.
Yeah.
All right. What property is being used in number A?
Distributive.
Okay. How about B?
Are we... Okay, hold on 1 second. Are we doing anything to it? Are we factoring it? No.
No. Because all they're doing is switching the positions of X and A. I would call that the associative property.
I'm sorry, excuse me?
The associative property is the one that says A plus X equals X plus A.
So we're just switching X and A.
That's the only difference between what's on the left side of that equation and what's on the right.
Okay.
Okay? So I believe that's the associative property. Number C. X plus y equals 1 times x plus y. I'm not sure what property that is called, but 1 times any number is equal to that number.
So it's just going to be the equal property, basically?
Yeah, I guess. I don't know. Some of these names they have for these properties, you learn them once and then that's the last time you ever deal with them. So I've been tutoring for 7 years and I don't know the answer to this because it never comes up.
What would you call it, like the equivalence property?
I'm not sure.
Okay.
I'll be totally honest with you. I don't want to give you an answer that I'm not completely sure about.
Okay, no worries.
Okay. Now, D. This might be the addition property. Once again, I'm not totally sure. In other words, if you combine the -3 and the 3, you get 0. But I don't know the exact title of the property because, like I said, that's not a standard question on pre-calc.
Okay.
Okay? Most of the rest of these I can help you very much with.
So equal and then addition. I'll search up the properties on that one.
Okay.
All right.
What's x to the a times x to the b?
Okay. Would that be x a b?
It's x to the a plus b.
And now, when we are multiplying, say two of something that's squared, would that be always a plus?
Well, here's the thing. If the base is the same, in other words, if I have b to the x plus, or b to the x times b to the y, same base, different exponents, you always add the exponents, which is one level less than multiplication. So when you're dealing with exponents, always remember that you want to do one level less than is being done with the bases. I'm multiplying the bases, therefore I want to add the exponents. You'll see as we go through the next one. In this case, we're dividing the bases. What's one level less than division?
Multiplication.
Subtraction.
Subtraction.
One level less than multiplication is addition. One level less than division is subtraction. And that's kind of the way I like to think of it. And then the third rule when dealing with exponents with a common base is this one. If you have x to the a all raised to the b, in other words, if you have exponentiation, which is what this is called,
right,
then it's x to the ab, which notice that multiplication is one level less than exponentiation. So I found that that's the best way to memorize these, is always remember that what you do with the exponents is never the same as what you're doing with the base. It's always one level less.
Right, so just to think of it as multiplication would be addition, division would be subtraction, and when we're multiplying, we're basically connecting the A and B.
This is called exponentiation. So when you have exponentiation, you have multiplication. In other words, let's look at some examples. If I had 2 to the third times 2 to the fourth, what would that be equal to?
It's going to be 2, 3 plus 4.
To the 7th. And if I add 2 to the 4th divided by 2 squared, what's that going to be?
We would be taking the 2 and basically squaring it.
Okay.
Like 4 minus 2.
Exactly. And finally, if I had 7 to the 8 all raised to the 9th power, what would that be?
So 8 times 9 is 45. No, 46.
72.
I'm so horrible.
Well, do you have a calculator in front of you?
I don't.
If you can get one, you should get one. In other words, you're going to need to do a lot
I have one on my computer, actually. All right, there we go.
Okay.
Alrighty.
Okay.
Okay, yeah.
All right, but that's your 3 basic rules for exponents. Is that if the bases are the same, and notice that they have to be the same. In other words, if I had 2 to the 3rd times 5 to the 7th, I can't do anything with that. I don't have the same base. I have different exponents,
so
but the bases are different.
Question, you can't answer it.
Exactly. I cannot simplify this. I mean, I could certainly figure out that 2 to the 3rd was 8, and 5 to the 7th is who knows what, and I can multiply it that way. But in terms of simplifying it into something, I can only do it if the bases are the same. In other words, these 3 rules, notice that x is always equal to x.
Okay, great. Okay, that's an easy way to do that.
Okay, number D. What does a negative exponent mean?
I'm not too sure.
Well,
Does that mean a negative?
It does not mean a negative number. It's one of the few times that a negative sign does not mean a negative number. What it means is the reciprocal. It's like that. So if I had, say, 2 to the minus 3, what would that be equal to?
2 to the minus 3, would that be negative 3 over, oh, actually no, 3 over 2?
No. Start with the reciprocal, which means 1 over what? 1 over 2 to the positive 3. 2 to the positive 3 power, which is actually 1 over 8. Notice that's a positive number. So just because we have a negative exponent, we still almost always have a positive number. The negative exponent does not mean negative. That's the most important thing to remember, is that negative exponents do not mean negative, that means reciprocal.
Okay.
Okay, let me give you another example. Let's just make sure you get it. 4 to the minus 3. What would that be?
So 1 over 4 to the 3rd power.
Correct. And the other thing about negative exponents is the other way to deal with them. If I had this, I can just take it to the other side of the fraction bar. That is the same as that.
Right.
So even if I have variables, if I have something, in other words, if I have the negative exponent in the denominator, like that, then I can just move the x to the other side of the fraction bar and make the thing positive. And that's an important thing to remember. That if you have negative exponents, just move it to the other side of the fraction bar, change the sign, and that's your answer.
Got it.
Okay. Let's look at E. Any number to the 0th power is equal to what?
1.
Yes. So it doesn't matter what x to the a is, x to the b, or x to the c. that thing is going to be equal to 1. Even 0 to the 0th power is equal to 1.
Is 1.
So even if those three numbers totaled 0, it wouldn't matter. No matter what those three numbers total, if I take it to the 0th power, I have 1. What does a fractional exponent mean?
A fraction of an exponent?
No, this is a fractional exponent. In other words, it's not an integer. It's a fraction. Something, say I had 3 to the 1/2. What would that mean?
3/2.
No. The denominator is the root. So that would be the square root of 3. And x to the 1 over n is the nth root of x. In other words, if it's square root, it's going to be 1/2. If it's cube root, let's say I had 4 to the 1 over 3, then that is the cube root of 4. So when you have a fractional exponent, the denominator is the root, the numerator is the power. What if you had something like this? Always do the denominator first. What is the...
So it would be the square root of 8.
Be the cube root of 8. What's the cube?
The cube root.
Right, because it's the denominator that's the root. So what's the cube root of 8?
Oh, wait, what happens? So you're saying the denominator here is going to be the root?
Always.
Just because 3 is in the denominator, which would
It's
mean
the cube root of 8, and then we're going to square that answer. Well, the cube root of 8 is 2, and 2 squared is 4. Now, I could do the numerator first. In other words, I could do 8 squared, which is 64, and then I could take the cube root of 64. That's also 4. But whenever you see these problems, always do the root first. It'll make it far simpler. Notice that when I did the numerator first, I had a number as big as 64. Whereas when I did the denominator first, I got 2 squared.
Right.
I never had to deal with a number bigger than 8. And
how did you find out the cubed root of 8, though?
Well, that's just something you learn. The cube root of 8 is whatever number multiplied by itself 3 times is equal to 8. Well, multiply that by itself 3 times and you get 8.
Right, okay.
Now, you could also look that up in your calculator, but that's one you should remember. In other words, you want to know squares of every number up to at least 10. What's 8 squared? What's 8 squared?
4.
8 squared. 8 times 8.
Oh, 64.
Right. What's 6 squared?
36.
Okay. So you want to have those memorized. All the single digit numbers. But the cubes you only need to memorize maybe up through this many. Up through 4. What's 2 cubed? That's 8. What's 3 cubed?
9.
Remember, it's 3 times 3 times 3.
So 3 times 3 is 9 times 3. Oh, is that 21?
27. What's 4 cubed? 4 times 4 times 4?
4 times 4 is 16.
Times another 4?
36.
64.
No, 64.
So these 3 here you probably want to put in your memory bank.
Okay. I will write this down.
Whereas the squares, you want to memorize all single-digit numbers squared.
Okay.
Okay. All right, let's look at number 4. This is a simple algebraic equation. What's the first step that I want to do?
Get rid of the fraction?
Yeah, I love that answer, because my first step in solving any equation that has a denominator in it is generally to get rid of the denominator, which is getting rid of the fraction. What can I do to get rid of the fraction?
Using the lowest common denominator?
Well, that's one approach. In other words, I could find the lowest common denominator between that and go ahead and perform that process. But there's actually a much easier way to do this. What can I multiply both sides by in order to get rid of all denominators?
2x.
Exactly. In other words, find your lowest common denominator and multiply both sides by it. And now, what's the left side become?
Okay, let me just write this. So, 2x. Okay, so basically we lost the 5, and then on this side we just have
What's this?
2.
When you distribute that, what does that equal to?
Well, it's going to become
8, okay. And then what's 2x
so,
times minus 5?
Minus 8 with the 10.
10x. Don't forget the x.
Right, 10x
And then what's the other side?
is just the 5.
Right. And now notice how much easier it is. We've gone from something that looked very complicated to something that's very easy. Go ahead.
So question, when I was distributing 2x into the 4 and 5, would I do 8x?
Well, you would multiply this times this.
Right.
And the x's cancel one another. So you end up with just 2 times 4. So you end up with 8.
Understood. Okay.
And then when you multiply the 2x times the minus 5, you end up with minus 10x.
Right.
So you don't totally lose the x yet, but you do lose all the denominators, and that makes it far easier to solve. So what's the next step here?
We're going to be bringing everything, and we're going to leave x by itself.
Okay. So how do I do that?
So are we going to be subtracting the 8?
Okay. It means I got minus 10x equals 5 minus 8, which is minus 3. What's the next step?
Okay. Wait, is that correct?
Uh-huh. What's the next step?
Okay.
In other words, all I did was I subtracted 8 from both sides.
Right, exactly.
Okay.
And then we divided.
Divide by
divide
what?
Negative 3.
By what?
Into the negative.
Divide it by what?
Negative 10x.
Just negative 10. Only the coefficient of x. In other words, our goal is to get it to this. X equals something. So we're doing everything we can to eliminate everything but the x.
Oh, okay.
Okay, so if I divided it by 10 minus 10x, I would have 1. So I want to divide it only by minus 10. And then the minus 10s cancel, and I'm left with just x. What am I left on the right side? What is minus 3 divided by minus 10?
could we even do anything with that?
Well, what's a minus divided by a minus?
It's a positive.
Okay, so that's what you can do with it. In other words, I can't reduce it, but I can simplify it. Right. Yeah, you don't ever want to leave an answer with negative signs if you can turn it into a positive. Okay, let's look at B. There's a particular way to handle, these are absolute value signs. If I stated that to you, that always translates into two equations. And the two equations are either x is equal to 3 or x equals minus 3. And that's how you do every one of these type problems.
Right, because there's only two ways to solve for it, right?
Well, the key is that, well, no, it's that it's always turns into two equations. And the key is to never change what's inside the absolute value. Okay, so what does this mean?
So would that mean 1 minus 2x equals 3?
Or, there's always an or.
1 plus 2x.
No, never change what's inside the absolute value sign.
Okay, so 1 minus 2x equals negative 3.
There you go. And now notice you have two different equations. And the reason I wrote them horizontally was because you now generally solve equations by going down. So let's go down. Solve the left equation. 1 minus 2x equals 3. What does that give you?
Are we doing what we did before? We're just isolating the x?
Yes. The goal is to end up with x equals something down there. So how do we isolate it?
So we are going to be minusing the 1.
Okay. So what's the next line?
So negative 2x equals 2.
And then what?
And then we're going to be dividing it by negative 2.
Okay. So the left side becomes x. What's the right side become?
Equals negative 2.
Now, what's 2 divided by negative 2?
Oh, is that a positive 2?
No, it's negative 1. Okay. If you're having difficulty with that kind of process, then you definitely need a calculator in front of you.
On the negatives and positives of things?
Things like that, yeah. In other words, I can't give you any better advice than to memorize single-digit multiplication, division, addition, and subtraction. If you have to always do those on a calculator, math is going to be incredibly difficult. But if you can do this in your head to come up with minus 1, math will be a lot easier. And that's all I can say. There's numerous ways to work on that, but if you don't have those memorized, in other words, if you don't have your multiplication and division tables with positive and negative numbers memorized, I would work on that. That nothing will benefit you more than that. Okay? Now we have to solve this one. In other words, this is only one solution. Now we solve that one. Well, how do I solve that one?
Minusing the 1 on both sides, so we're going to do negative 2x.
Equals what?
4.
Negative or positive?
Negative.
Negative 4. In other words, minus 3 minus 1 equals minus 4. This is the kind of thing that if you don't know that, work on it. That's the kind of thing that nothing will help you more than knowing how to add and subtract positive and negative numbers. I find a lot of students that really ultimately is their biggest problem. It's not the algebra or the precalculus or any of that. It's that they never really got this. And you just cannot advance in math unless you get that. Okay? So what's the last step here?
We are going to be dividing the -2 on both sides.
Okay.
The sign for x.
So what is x
so
equal to?
Would this be +2?
Yes. So those are your two answers. And if you go back and substitute both of those, you will see that that's true. In other words, 1 minus a 2 times a minus 1 is equal to 3. And the absolute value of 3 is 3. Also, if I plug in this solution, I get 1 minus 4, which is -3, but the absolute value of -3 is also 3. So both of these are valid solutions. And usually absolute value problems almost always are going to have two solutions. It's rare that you'd have less than 2. I can't even think of a problem that would have less than 2.
Gotcha.
All right. Now, this is an absolute value problem, but it has an inequality sign instead of equal sign. Well, let's go through that. If I say that is greater than 3, that means two things, again. The first thing is always whatever you've written without the absolute value sign. And in an inequality, the second thing, never change what's inside. But in this case, you have to change both the sign on the number and the direction of the inequality. So,
I see.
okay, so no matter what is inside, I'm going to make it. In other words, as long as you understand this, then let's do the problem, which is 1 minus 2x, absolute value of that is less than or equal to 3. So what's the first thing I would write?
You wouldn't change anything, right? So it's going to be 1 minus 2x is less than or equal to 3.
Or what?
Or 1 minus 2x is greater than or equal to -3.
Exactly. You have to make two changes in the second one. You have to change the
direction. And is it like a universal rule with interval notation, like no matter what, you need to change the second one?
Yes. The rule I kind of remember is never change what's inside the absolute value. And if it's an inequality, you have to change two things on the or part. You have to change the direction of the sign, and you have to change the sign of the number. So let's finish this. What's the rest of it? In other words, now vertically we solve each one. What do we get?
Well, would we be doing the same thing? Would we be minusing?
Correct. There's only one major difference between solving an equation and solving an equality. And that is that whenever you have to multiply or divide either side by a negative number, you change the direction of the sign. So let's do the first step. First step is to subtract 1. Well, that's not multiplying or dividing by a negative number. That's just subtracting 1. So we get that.
-2x.
Now you have to divide by a negative number.
So that means that we need to change sign.
Right. Reverse the sign of the inequality. And what's 2 divided by -2?
-1.
Yes, and make sure you do both. Really easy to make the mistake of assuming that you didn't divide by a negative number. In other words, once again, there's two things you have to do whenever you divide or multiply by a negative number. Okay, let's go over to this one. Now I got minus 2x is greater than or equal to what?
5.
What's minus 3 minus 1?
Oh, I'm sorry, I'm doing 2 over here. So it's going to be 4.
Negative 4. In other words, minus 3 minus 1. There's the subtraction sign. Change it to an addition problem by changing the sign and changing the sign of that. So that's the way I do all my subtraction problems. And nobody gets that wrong. Everybody knows that's equal to minus 4.
Right.
But a lot of people will get this wrong because the reason I think is because they're not sure which is the subtraction sign. We have two little hyphen
And
marks.
which is negative.
What this really is a minus 3 subtract a positive 1. So if you choose to change all of your subtraction problems to addition problems, first of all you have to locate the subtraction sign, which is that. If I'm going to change that to a plus, then I have to change the sign of what was being subtracted. And now it's minus 3 plus a minus 1, and that's easy. That's minus 4.
Right, okay, so that's going to be the...
So now what? There's still one last step. How do I isolate
okay,
x?
we're going to be doing negative 2, so we're actually dividing by a negative number.
Okay. So it leaves x on the left. What's the direction of the sign?
X would be less than or equal to 2.
Yes. Okay, now we have our answers. We have x, if I were to draw a number line, with that at 0, that at minus 1, that at 2. Well, I know x is greater than minus 1 and less than 2, so x is in this territory right here. It's me. And if I were to write that in interval notation, which is what they request, how do I write that in interval notation? Always start from negative infinity. Well, excuse me, not in this case. In this case, interval notation is minus 1 to that. And I use brackets because of the equal sign. If it was just greater than, if it was greater than minus 1 and less than 2, I would use parentheses. So that's the difference.
Oh, okay. So that's a rule also of thumb.
Always.
Okay, so basically you're using the
Right.
actual bracket. Okay.
Yeah, now let's look at a slight alteration of that just so I can explain it. Let's assume our answer was x is what? X is less than negative 1, excuse me, or greater than 2. Well, what would interval notation look like? It would be negative infinity to negative 1
And negative 1.
with a bracket in combination with bracket 2 to positive infinity. And infinities always have parentheses, never a bracket with an infinity. So,
Right.
so this would be the answer for that region of the number line
Right.
in interval notation.
Got that. Okay.
Okay, let's see. Which one was that? One was C, right? And let's do D.
Okay.
So here, I'm going to go down a step. You want to take the very first step when you have an absolute value sign is to isolate the absolute value. In other words, in the previous problem, it was already isolated. But in this problem, it's not. There's a 5 being added to it. So the first step is to move that 5 to the other side.
Right, so we're going to minus it.
Okay, so now we have 1 minus 2x greater than 3. And remember, it's only when you multiply or divide that you have to change the direction of the arrow. In this case, I wasn't multiplying or dividing, I was subtracting. Now,
I'm sorry, can you repeat that again?
Yeah, notice that I only change the direction of the arrow when I am multiplying or dividing. In this case, I was subtracting 5 from both sides. So with subtraction, you don't need to change the direction of the arrow.
So it's different than C in essence.
Yes, in C, well, not yet, because we haven't finished it. As we finish it, we're going to have to do the other stuff. But, okay, so what does this mean? Tell me the 2 things that this means.
Okay, so it means, right, so 1 minus 2x greater than 3.
Or
1 minus 2x is less than negative 3.
Okay, solve each of those. The left side.
Second, 2x is greater than 3. Okay, now the left side, we're going to be doing the same thing we were doing, so it's going to be negative 2x is greater than 2. And then we're going to be dividing and isolating our x. So x would be greater than negative 1.
Not greater. Remember, we're dividing by a negative number to get x.
So we change the sign. X is less than negative 1.
Right. Just remember that whenever you have to multiply or divide both sides of the inequality, you change the direction. And on the right side,
multiply or divide.
Right. Not add or subtract, but multiply or divide only. On the right side, what do we have?
Okay, so then we're going to be doing the same thing. We're going to be minusing 1 on both sides, and then it'd be left with negative 2x is less than negative 4.
Then?
And then negative 2 divided would be x is greater.
Good. Now notice what this answer is. On the number line, if that's 0, that's minus 1, and that's 2. This is a case where it is, and it's like that. So what would the interval notation for this answer be? And remember, I got to start with negative infinity.
Right, so it would be negative infinity in parentheses, negative 1.
That's what's in parentheses. And this time, I need a parentheses on the negative 1 because there's no equal sign there also. It's just less than negative 1.
Oh, okay. So that's why there's not a bracket?
Exactly. That's the difference between a bracket and a parentheses. In combination with what?
In combination with infinity.
No.
Parentheses infinity.
Hold on. The infinity always goes last.
Oh, right. Okay, so.
The negative infinity always goes first. The positive infinity always comes last. And you're right. That's a 2. And it's a parentheses because it's got to be greater than. All right.
Which first? Okay.
Now, this one is a little tricky. Now, basically, what I want to do is turn this into something that has 1 over x plus 4 in the denominator, in the middle. In other words, when you have an inequality thing like this, I can use the same principles as I use with algebra. I can add any number I want to all 3 parts. So I can add 4. So I can add 4 to that part, I can add 4 to that part, and I can add 4 to that part. Which gives me 1 is less than x plus 4, which is less than 4. So starting from this expression here, I can turn it into this expression. This expression here is the same as what they gave me. So all I've done is added 4 to each of the 3 parts.
And why did you add 4 to every single part?
Because I'm trying to make the middle part look like this. And the first step is to add 4.
And is that because x plus 4?
Yeah.
So I'm just going to be adding each thing.
Right.
4, even the 0. Okay. And then we would be left with right. So negative 6 plus 1.
Now, how do I make this look like this? Well, I take the reciprocal of everything. And the thing about taking the reciprocal is when you take the reciprocal, you also change the direction of the sign. So the reciprocal of 1 is 1 over 1. Now I got to change the direction of that sign to take the reciprocal of that. And change the direction of that sign to take the reciprocal of that. And now I have my answer. A is 1, B is 1/4.
Oh, I see.
Now, it's a good idea on this one. You don't come into reciprocals very often with inequalities. So I actually had to test a number. But let's test a number.
Okay.
How about when x is equal to, oh boy, got it wrong. For some reason when I did this before, oh, I got it right. When x is 2, you would have 1 is greater than 1/6, which is correct, but that is not greater than 1/4. So I'm doing something wrong here. It looks almost like I have to change the sign on that one and leave the sign on that one the same. Let me think for a moment. Yeah, that's the only way it would work. If I had, let's play with this a little bit. X, if 3 is less than x and x is less than 5, then we know x has to be 4, right?
Right.
Well, let's take the reciprocal of each.
1/3, 1 over x, and 1 over 5.
Well, we know x is 4. Well, 1/4 is actually less than 1/3, but it's greater than 1/5. So here's a rule that I did not know until just now. And that is when you have this kind of an inequality, and you take the reciprocal of all three items, you change the sign on that one, but you leave the sign on that one the same. Notice that 1/3 is indeed greater than 1/4, but less than 1/5. Hold on, that's not right. 1/4 is greater than 1/5. So this would indicate that I would change the sign on both, which is what I thought in the first place. But for some reason,
that was incorrect as well.
You know, let's go back and look at that problem. I might have just made a math error. In other words, is this statement true? No matter what x is, 1 is going to be greater than that. And when x is 3, this isn't even true. So something's wrong here. Hold on, let's go back. Here I added 4 to both sides. In other words, if x is greater than -3 and less than 0, then x plus 4 has to be less than 4 and greater than 1. And that's actually a true statement. It just means that x is negative. If x has to be an integer, it would have to be -1 or -2. Now, okay. I was right the first time. You turn the direction around on both. Notice that the only allowable answers are x equal -2 or x equal -1 to satisfy the first part. Well, if I let x be -2, then I have 1 is greater than 1/2, which is true, and that's greater than 1/4, which is true. If I let x be -1, then I have 1 is greater than 1/3, and that is also greater than 1/4. So I apologize, I haven't done this kind of inequality in a while. You definitely do this. In other words, when you take the reciprocal of all three parts, you change the direction of both signs. It's the same, taking the reciprocal is the same as dividing everything by -1 or multiplying everything by -1. Has the same effect. You have to reverse the sign. All right. Now, in this case,
So the answer would be A is 1/1 and B is 1/4.
yes. Yeah, well, hold on. Yes. A is 1 and B is 1/4.
Okay.
But the key is the direction of those signs are the opposite. Well, actually, the only question they're asking for is A and B. So you're right. The answer is A is 1, B is 1/4. They get a little harder. First of all, let's see if we can state the two things that this means.
Oh, here we go. So it's going to be x squared plus 2x plus 1 equals -5. Or x squared plus 2x plus 1 equals 5.
Now, solve both of those. How do you solve the one on the left?
So we're going to be like terms first?
Well, this is
Or
a quadratic. The typical way to solving a quadratic is to make one side 0, right? Everything else is put on one side and you leave 0 on the other. In other words, I would add 5 to both sides. For this one over here, I would subtract 5 from both sides. However, that's going to leave you with two quadratic equations that you're going to have to use the quadratic formula to solve. In other words, it would give you x squared plus 2x plus 6 equals 0. Cannot solve that by factoring. You have to use the quadratic formula. And on this side, it would be x squared plus 2x minus 4 equals 0. You can also not factor that. You'd have to use the quadratic formula to solve that. Anything you cannot factor, you got to use the quadratic formula. You with me?
So right. So can we leave the answer like that?
No. What's the quadratic formula?
I have that in my notes somewhere.
If you have to memorize it, then you want to memorize it. If you're allowed to not memorize it, in other words, have a sheet of notes, that's what it is. Now, the most important thing is you know what A, B, and C are. In this case over here, what's A, B, and C?
X.
No, A is 1. It's the coefficient of the x squared term.
I see.
B is the coefficient of the x term, and C is the constant. So for the one on the left, A is equal to a 1, B is equal to 2, and C is equal to 6.
I see.
That's how the quadratic formula works. For this one over here, A is 1, B is 2, C is minus 4.
1, 2, and minus 4. I understand now.
Okay. That's going to give you 4 solutions because the one on the left is going to produce 2 solutions and the one on the right is going to produce 2 more solutions. Whenever you use the quadratic formula, you almost always have 2 solutions for each. So we actually end up with 4 solutions, which kind of makes sense because quadratic formulas in themselves give you 2 solutions and absolute values give you 2 solutions. So you expect to find 4 solutions here.
Right, that makes sense.
There is a slightly easier way to do this only because I noticed that x squared plus 2x plus 1 is the same as x plus 1 quantity squared. In other words, there's an easier way to do this than using the quadratic formula.
Right, because this is our first chapter, and he just started teaching the quadratic formula, so I'm surprised that this is even on our first.
How do I solve that?
Okay, can you first tell me how you got that? You just factored it?
Yeah, that's all I did was factor x squared plus 2x plus 1. And it factors into x plus 1 times x plus 1.
X plus 1 squared.
Right.
Equals negative. Right.
So how do I solve this kind of a problem? If I told you that x squared equals 16, how would you solve for x?
How would I solve for x? Would I divide x?
Take this. That's a good thought because that gets you to x on the left side, but you want x on the left side by itself. You don't want any x's on the right side. In other words, if I were to do that, which is what you suggested, then I would have x equals 16 over x. That's not solving for x. In other words, when they say solve for x, you want nothing but x on the left side and nothing but numbers on the right. So that's the problem with that method. However, what I could do is take the square root of both sides. When you take the square root of x squared, you get x. And when you take the square root of 16, you get plus or minus 4. Not just 4, but plus or minus 4. Whenever you solve an equation by taking the square root of both sides, your answer is always going to begin with a plus or minus.
And this is for square root?
Yeah, this is for equations. Okay? Notice that over here, the next step is to try to isolate x plus 1. So I'm going to take the square root of both sides. What's that leave on the left?
X plus 1.
What's it leave on the right?
The square root of -5 would be plus or minus, I'm not sure what the square root is.
5i.
I'm not sure what the square root of 5 is.
Well, it's the square root of 5 is the square root of 5. The problem is the negative sign. When you take the square root of a negative number, you get an imaginary number.
Okay.
Have you had imaginary numbers?
No.
Well, they're not that hard, but they're a little strange. That's what I is equal to. The square root of -1. It's called an imaginary number because there is no such number. You can't tell me a number that when multiplied by itself equals -1. It doesn't exist. But for math purposes, there's a great usefulness in having an imaginary number. When you get into higher math, calculus and stuff like that, there will be a lot of places where I is very useful to have this concept, even though it's kind of like an imaginary friend. They don't exist, but it's useful from a mathematical point of view. So if I said, what is the square root of -5 equal to? Well, the first thing you would do is to break it up into the square root of 1 times the square root of 5. And the square root of -1 is I times the square root of 5. So that's how I got that part of the answer. And this part is always, whenever you take the square root of both sides of an equation, begin your answer with plus or minus. Okay, now we're not quite done. We're not quite done on the left side because we haven't isolated x. One last thing do I have to do? Okay, so now my answer is, and I put my real number there in front, and I have plus or minus the square root of 5i. Make sure that that I is outside the radical sign, as opposed to this. That is completely different. In that case, the I is inside the radical, but in this case, it's outside the radical. And almost always you want it outside the radical. It's not until graduate school math that you would, if you were, getting a master's in math, that you would ever deal with the I being inside the radical. So that's one answer. And it is an imaginary answer. In fact, it is two imaginary answers. Because what this means is that x equals -1 plus square root of 5i, or x equals -1 minus square root of 5i. So just the left side of this thing produced two answers. Now let's solve the right side. And let's solve it the easy way, as opposed to using the quadratic formula. Take the square root of both sides. What do you get?
We're going to get x plus 1. Well, radical 5.
Always start your answer with Believe it or not, that is the toughest thing in math to teach. I kid you not. I've tutored for 7 years, and that's the hardest thing for students to learn, is to always start your answer with plus or minus when you're taking the square root of both sides of an equation. So it's plus or minus square root of 5. And now the last step over here is to subtract 1 from both sides. Again.
Then we're going to do x equals negative 1 plus minus 5.
And that answer is this or this. And these are 4 separate answers. Notice both of the answers on the left are imaginary numbers or complex numbers, whatever you want to call them. Both of the answers on the right are real numbers. You only have 2 types. You have real numbers and you have complex numbers. If there's no imaginary part to it, then it's a real number. If there's an imaginary part to it, it is a complex number.
Right.
So here you have 2 complex answers, and over here you have 2 real answers. There are 4 answers to this problem. And notice that when we did it this way, it was much, much easier than plugging it into the quadratic formula.
Quadratic formula.
Yeah, but had I used the quadratic formula, I would have come up with the same 4 answers.
Right.
They're not any different. It's just that because of the nature of this problem, where the quadratic they gave me was a perfect square, in other words, that was x plus 1 squared, I could use that technique. Had that been x squared plus 2x plus 2, I couldn't have used it because it's not a perfect square anymore. I would have had to use the quadratic formula. In other words, solve quadratics basically one of 3 ways. You can factor them if they're factorable. You can use the quadratic formula if they're not factorable. Or if they are perfect squares. If the quadratic happens to be a perfect square, then you can take the square root of both sides, which ends up being slightly easier than using the quadratic formula.
Okay, so we got that one.
Okay. The easiest way to understand 7 is to do part B and C first.
Okay.
How would I write this number as a ratio of integers? In other words, first of all, what does that line mean? What does that line over the 1/7 mean?
It's repeating.
Right. So this real fraction is, and it's only the part that the line's over that's repeating. And it goes on forever like that. So how would you write that number? It would be 5 plus 17 over 100 plus, in other words, that covers that. And then this part is 17 over, not 1,000, but 10,000. Got to add 2 zeros. And then this part here, 17 over 1 with 6 zeros. And so forth and so on. So when you have a repeating decimal, you can write it as integers this way. And then I don't know how they want you to write the rest of it. It's an infinite series is what it is. And it doesn't look like you've probably gotten to infinite series. So I suspect that this is close to what the answer they want to see.
Okay, so basically it's a ratio of integers. So I don't know how he taught us, but he basically said just 2 would I be like, I mean, mean, I could probably write this. I just don't know how he wanted us to.
Well, let's see.
But I mean, this would be.
Here's what I suspect he wants you to do. Plus 17 over 10 to the n plus 2. However he wants you to represent that. In other words, if you've had infinite series, there's a way to talk about these. But if you haven't talked about infinite series, it's a difficult thing to write as a ratio of integers because it goes on forever. In other words, I can't write it as a ratio of integers. I can write it as a ratio of the first 4 parts of it, but the rest of it just keeps adding zeros to the bottom.
Yeah, I mean, I guess that would be, I mean, it's an acceptable answer if that's the case, because
he'll know what you're talking about if you write this. As long as you write the dot, dot, dot.
The dot, 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 because it continues.
Okay. Now let's look at C. 2.347, where only that has the line. So let's write out the first few digits of this. What comes next?
So we would do 2.3 plus.
Well, what's next is repeating 4 sevens.
Right.
Now, if we want to write that as a series of ratio of integers, what's the next thing?
100.
No, the 47. What's the denominator of that 47?
100.
10,000.
10,000.
Excuse me, 1,000. In other words, if I said, what is that number? That's equal to 47 over 1,000, right? And that's what I'm adding. If I took 2 and added 3/10 to it, and then added 47 over 1,000 to it, I would get that part right there.
Right, and then we would leave it at that?
No, that is not a complete representation of the number. If I really want to show the teacher that I understand the problem, then this has to have 2 more zeros than the previous one. Dot, 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 dot. I don't know what the teacher's notation would be for this if he were to represent it as an infinite series, but as long as you get the idea, that's important. If I am repeating 2 digits, then the denominator is always going to increase by 2 zeros each term. If I'm repeating by 3 digits, in other words, if there was actually a line over this, then the denominator would increase by 3 zeros each term. Okay? So I think if you put that enough part down, you'll get a lot of credit. You may not get exact credit because, like I said, I'm not sure exactly how he has taught you to express these.
But right, he'll understand that I understand.
Yeah. Okay, now let's go back to A. We have a number, w dot xy. Well, let's express that as a ratio of integers. W plus what?
W plus x.
Xy.
Xy over 100.
Uh-huh.
And it's going to be xy over 10,000.
Good. Just know you have to add 2 zeros to the denominator each time.
And then we would do the same. We would add 2 more zeros on top of that.
For every term. And it goes on to infinity. So like I said, that becomes a question of notation, and I'm not sure how he wants you to write that. If you're writing that in sigma notation, you haven't had sigma notation, have you?
No.
Okay. If I was writing that in sigma notation, it would be this. It would be W plus the sum of xy over 10 to the nth as n goes from, not quite this. If I'm only adding 1 0 each time, then it would be like that as n goes to infinity. If I'm adding 2 zeros each time, I would have to give a little more thought to it. But if you have not been taught sigma notation, then that's not the issue. This is the best I can do for you. Okay? And I think that'll get you the right answer for your teacher. Or at least most. 8a, again, is set theory. And I do not have expertise on set theory. Set theory really is not a part of typical Common Core pre-calc.
Okay.
Okay, so I don't know the answer to 8. And I'm not even going to venture a guess. I can help you with the ones I can help you with, and the ones I can't. I can help you with everything else on this thing.
Alrighty, so set theory I will try and figure something out about.
Okay, so number 9 is just converting interval notation to inequality notation. Well, if I'm in the interval 2 to 5, that means x is greater than 2 and less than 5. So that would be the inequality notation.
I'm sorry, how did we get that? We got 2 is less than x?
Yeah, let me do this the way. In other words, if the interval is 2 to 5, then what that means is x is greater than 2 or less than 5.
Is that how it always is?
Well, let's go through each one of these and I think you'll pick it up. Okay. If the inequality notation is this, what would the interval notation be?
So x is going to be 2. That's going to be.
That's the answer.
-2. And 5.
You see why I use brackets?
Okay. I just looked up at the screen. Okay, yeah.
Because it's less than or equal to. Okay. So let's do the third one.
So we used brackets for both of them?
No. We used the first one, it had parentheses on it. So I used greater than and less than. Remember, this one, they're giving us the inequality notation. We have to give the interval notation. Because that's a less than or equal to, and that's a less than or equal to, I got to use brackets.
Okay.
So this one here translates to bracket. And let me get rid of this because that's no longer the interval. But bracket minus 2 comma 5. That says the same thing. That says that x is between minus 2 and 5, but it can be equal to minus 2, and it can also be equal to 4. Okay. Now let's write the inequality notation for the third one. We'll do it.
Would that be
like this.
That x is 3?
Is it greater than or greater than or equal to?
Greater than or equal to.
Okay. Goes on the other side of that.
And then greater than or equal to, no, infinity is always parentheses, right?
Right. In other words,
So
infinity
just
goes
greater
there,
than,
and that's all you need. In other words, the interval that goes from 3 to infinity, including 3, is this interval. This is just the inequality notation.
right.
That says the same thing. That says x is between 3 and infinity, and it can be equal to 3. It's not just greater than 3, it can also be equal to 3. Okay, let's do the fourth one. This one, they give you the inequality notation. They want the interval. What's the interval that represents?
It's going to be x, well, in brackets, x, comma 5.
No, it always, if it's less than 5, where would you start on the line? In other words, if I draw a number line and there's 5,
Negative
goes all the way to negative what?
negative infinity.
Right, that's where you got to start that from for interval notation. What's the right side of that?
So negative infinity and 5.
And bracket or parentheses?
Bracket.
Exactly. In other words, this says the same thing as this. It says x is anywhere from negative infinity to 5, including 5.
Right.
Okay? And finally, the last one. That's always the way you start it. You have an x there. What goes to the left of that equality sign? For this one here?
X.
X is greater than what?
Greater than or equal to.
No, greater than negative infinity. And less than what?
Infinity.
And you never use the less than or equal to when you're dealing with infinity. In other words, infinity always has parentheses and never an equal sign. It doesn't make any sense to say x is less than or equal to infinity, because that presumes that infinity is a number, and it isn't. Infinity is not a number. Infinity is a concept. It's increasing without bound or decreasing without bound. And so therefore, it never has a bracket or an equal sign. Okay?
Right.
Now, incidentally, you will get a copy of this recording. I'm recording this. So if you're concerned about taking notes and stuff like that, you'll be able to review this session. It's in a YouTube file. You can fast forward it, so forth and so on.
Oh, and question, can we extend the time?
Sure. Want to go to?
Okay, because I would really
I
love
can go to whatever.
piece.
You can go to whatever time you want.
Okay, great. I will make sure I take care of that.
10 is a classic problem, which is finding the equation of a straight line. And to find the equation of a straight line, you need either 2 points, or you need point slope, or there's a third standard format. And I'll talk about that in a second. Point slope. What is the general formula for point slope?
Is that y equals mx plus b?
That's slope-intercept. point slope is y minus y sub 1 equals the slope times x minus x sub 1. Notice the name, point slope. It means we have a point and we have a slope.
Right.
So they've given us 2 points, so we can pick either one of those points, but the first thing we need is slope. We need to figure out what m is. What is m in this case? How do you figure out slope?
So how to find m.
Yeah, in other words, if we're going to put it in the point slope format, the best thing to do, well, you know what? There's a couple of ways to do part A. Regardless of which way you do it, you got to find slope. So, I'm sorry, let's go back and find slope. Slope is, what's the word definition of slope?
It's where the point meet.
It's rise over run. That's what you always want to remember. You'll never get it wrong if you remember that. If I have a line like that, the rise is that distance, which is what? That's the difference in the y-coordinates. The run, I want to figure out the slope between those 2 points. I do the rise divided by the run. The run is that distance, which is the difference in the x-coordinates. So 40 years from now, when you're long done with math, you want to remember that slope is rise over run. You'll always remember that. You'll always be able to come up with this.
The formula.
Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That's hard to memorize. Rise over run is not.
Right.
In this case, our 2 points are 2, 1 and 4, 5. What is our slope?
Well, thinking about that, y2 would be 5
Okay.
minus 1 over x2, which is 4 minus 2, which would be 2.
So that's our slope.
That's our slope.
Now we have slope and 2 points. Because all we need is slope and 1 point to put it into this format. If m is 2, then tell me what that would be. And pick either point you want.
It could be any of them?
It's either this one or this one.
Okay, so,
What's y sub 1?
1.
Slope is 2. What's
Equals
x sub
2.
1?
2.
There's your point slope format. And that's in final format.
Right.
In other words, you don't have to simplify that. That's in point slope format. That's the proper answer. Okay?
And I could choose each of the points I would like. So it would still be okay if I were to use y minus 5 equals 2 x minus 4.
Yes and no. I wouldn't do that. I would leave it in this format. This is point slope format. The second question says, okay, now give it in slope-intercept format. Well, slope-intercept format is where you have y equal mx plus b. In other words, slope-intercept is y equal mx plus b. Well, it's all I need to do to get mx plus b is to simplify that. So now simplify it. So you have y minus 1 equals 2x minus 4. Move the 1 over there. What do you get?
2x minus 4, and then we're going to minus the 1.
Hold on. We're going to add 1. Always do the opposite.
Oh, sorry. Right. Add 1, and then would that be -3?
That's slope-intercept format. Notice that it was very easy to go from point slope to slope-intercept, as all I had to do was simplify. But I wouldn't simplify that, because point slope format, that shows that you've got it in point slope format. If you give this as the answer, you're going to give the same answer for part A and part B. And it is the same equation, but this shows that you know that's point slope. This shows that you know that's slope-intercept. Now, what is standard format? There's 1/3 format that you have to know. Standard format, let me tell you what it is. That's ax plus by equals c. So take this equation and put it in standard format.
And A represents what?
Well, it's the coefficient of x. There's A right there, but it's on the wrong side of the equation. We got to move it over to the left side. So that would be
-2x?
plus y, 1y, equals minus 3.
And what does B symbolize?
B is the coefficient of y. In this case was 1.
So we would just leave it as -3.
And that's the constant. I didn't do anything but leave the -3 on the right side. As all I did was subtract 2x from both sides of the equation to get this.
Right, so we subtracted 2x from one side, and it would leave us with -2x.
Right. But notice that this fits the standard format. I've got the x on the left side of the equation first, then I've got the y, and I've got the constant.
Right.
And the other thing about standard format is no fractions. If I had a fraction here, I would multiply everything by that denominator to get rid of the fraction.
Right.
In other words, if I had this equation, that's not standard format because the coefficient of x is a fraction, not an integer. So I would want to multiply left and right side by 2 to get x plus 2y equals 6. That's standard format. It's the same equation. Understand that it's not a different equation. It's the same equation. But it is all integers, no fractions.
Right, makes sense.
Okay. Now, the key thing to understand is that all three of these things are the same equation. In other words, my slope-intercept, my standard format, and my point slope are all the exact same equation. They're not different. Just in different formats.
Just in different formats, right.
Yeah, if I solve this for y, if I solve all three of them for y, I get y equal 2x minus 3. It's just knowing the format. And the thing you have to know is the general format. And the three general formats are point slope. And let me just give you a hint on how to memorize this. Notice that if I were to divide both sides by x minus x of 1, I would have this. Well, that's kind of the definition of slope. Rise over run.
Right.
So when you write point slope format, make sure that if you were to solve for m, you've got rise over run. Slope-intercept is the first one you learn, and that's the one most people use. That's that one, which is merely solving it for y. And then finally, standard format is some number of x plus some number of y equals some number, where a, b, and c are not fractions. So those are your three formats, but it's important to know that they're all the same. In other words, you can take one equation and put it into all three formats.
Right.
All right. Here it says, find the equation of the line in any form that is perpendicular to this equation. Well, the easiest way to do that is to put this into slope-intercept format. So let's start by doing that. What is it in slope-intercept format?
Would that be?
Remember, it's got to look like y equals mx plus b.
With these points, 4 and 3?
Well, how would I turn this into y equals something? What do I do with this?
You bring it over.
Okay, so what am I going to have?
So y equals minus 2x.
No. Remember, you always have to do the opposite. To move something to the other side of the equation, you got to change its sign.
So y equals 2x minus 3.
Same equation. Those are both the same thing. But now we know what the slope of this line is. What's the slope of this line?
It's 2.
What's the slope of the perpendicular line?
1 over 2.
It's the negative reciprocal. It's not only just the reciprocal, but it's the opposite sign. In other words, if I had a slope of 2 and I want the perpendicular, notice that the perpendicular line has a negative slope on it. The perpendicular line always has the opposite sign on the slope from the line you're looking at. This has a positive slope, this has a negative slope. So take the negative reciprocal. So the equation of the perpendicular line would be what?
So we can do y equals negative 1 over 2 x minus 3.
Well, we don't know that it goes through that same point. In other words, if I had a graph and I had a line and I had a perpendicular line, that perpendicular line isn't necessarily going to go through that same point that that one did. So in this case, I leave it as plus b. The thing is that they have told us that this equation, this line, also goes through the point 4, 3. So how can I solve for b? I have an equation that has 3 variables, but I know 2 of them. I know what y is and I know what x is. So I'm going to be able to solve for b. But how do I do it?
Maybe dividing?
Well, I substitute the y point for 3, and I substitute the x point for 4. So I have 3 equals minus 1/2.
Oh, we plug in the points.
Yeah,
Okay.
exactly. And now notice, now I have one equation and only one variable. I'm going to be able to solve for that. So I get 3 equals 2 plus b.
2.
B equals 1. Now I know that that is 1. So my answer is y equals, I know the slope is negative 1/2 x plus 1. That's my answer. That equation goes through this point. You could plug in that point and it would satisfy that equation. And the only thing we needed was the slope of this equation. So we used the fact that the perpendicular was the negative reciprocal to come up with the slope. And then we used the point to figure out what b is.
I see. Oh, these aren't too bad. It's just about knowing the different ways of writing it.
Yeah, really. If you know your 3 standard formats, then these all become pretty easy.
Right. Okay. Not so bad.
Now, 11. Did we not do 11 already?
No, we didn't. We're on the last page, though, which is a good thing.
Hold on. 11 is the same as 5. Is it not 1 over
11.
x plus 4?
Oh, my goodness. Did he repeat a question? He might have.
Yeah,
that might be a typo.
They're exactly the same.
No way.
Yeah. Remember we came up with A was 1 and B was 1/4? And the sign, they're the same question, 11 and 5. The funny thing is that this 5 was worth 4 points, and 11 is worth 4 points. Less than. Less
You're
than.
absolutely right. Yep, they're the exact same thing.
Yeah, they are. Okay. All right, let's talk about midpoints. I assume you want to go through the end of these 2 questions. Okay. If you have a midpoint, let's look at the xy coordinates. Let's say I have a point here that's 6, 5. Now let's make it all even numbers. 6, 8. Left-hand point is 0, 1. Okay? Those are my 2 end points. Well, how do I get the midpoint?
Is there a formula for this, or?
Well, the concept is that it's halfway between the x coordinate and halfway between the y coordinate. So what's halfway between 0 and 6?
3.
And I get that by adding 6 to 0 and dividing by 2. What's halfway between 8 and 1?
4.
No, halfway between 8 and 0 would be 4. But halfway between 8 and 1, use the same system. Add the 2 numbers and divide by 2.
What was the system again?
Add the 2 numbers and divide by 2 to find the halfway point.
Wait, hold on. I need to make sure I'm understanding this. So, can you repeat how we got 3 again?
Sure. We added 6 to 0 and divided by 2.
Okay, so we have 6 to 0 divided by 2, which gave us 3. So then we're going to be adding 8 plus 1, which would give us 9, and dividing it by 2.
Right. Okay, now let me give you a slightly harder one involving negative numbers. Now that point's minus 4, minus 4. And this point is 5, 7. Now what's the midpoint? Is this point right?
5. Plus negative 4.
Is what?
Which Would that be -9?
No. 5 plus -4 is 1. Remember, you've got to be halfway between these 2 points. Think of it as a number line. There's -4. There's 0. There's +5. If I want the point that's in between -4 and 5, it's clearly got to be somewhere around there, right?
Right.
Okay, well, if I add 5 to -4, I get +1 divided by 2. That looks reasonable for an x coordinate, 1/2. If I got 6 as an answer, that can't be right. It's got to be between -4 and 5. And it's got to be halfway in between. It just so happens that the way you find the halfway point is to add the 2 numbers and divide by 2. So plus 1/2 is the x coordinate. What's the y coordinate?
So plus 1/2 would be the x coordinate.
Mm-hmm.
So would we be doing the same thing? We'd be
Exactly.
doing 7 plus -4
Correct.
divided by 2,
So
which
what
would give
is,
us 1.5.
I prefer to write it as an improper fraction. Believe it or not, improper fractions are far more useful than proper fractions. Even though it seems strange, but when you get into trig, you're dealing with nothing but ratios. So 3/2 is a much better answer than 1.5 because 3/2 represents a ratio. Okay. Now, let's say that I have the opposite problem. Let's say that I know the midpoint, but I don't know the other end point. But the midpoint is 1, 2. So how can I figure out, in other words, this problem here is they give you the first point, and hold on a second. So that's the midpoint of the line. Now let's just do it the way they're doing it. In other words, well, now let's do my problem first, and then we can apply it to this. Okay? This question 12 is giving you the endpoint and the midpoint, and it wants the other endpoint. Well, there's a key way to do this, not double. We know the distance from here to here on the x-axis has to be the same amount as from there to there in the same direction. So you're right, it's 5. And are we going up or down?
We're going down?
No, we're going up. We went from here to there. That's going up. So to find the other endpoint, I have to keep going in that direction. 5 more. So what's the endpoint? X coordinate of the endpoint going to be?
Would that be 10?
6. 5 more than 1.
Oh, 5 more than 1.
Yeah. Now notice that 1 is halfway between 6 and -4. That's always the key, is the midpoint has to be halfway between each of the coordinates. And it's just that when they give you the midpoint, it's a little harder to figure, now what's the y coordinate? How far did I have to go on the y-axis, and was I going up or was I going down?
You're going up 6.
Okay, so keep going another 6 in the same direction. What do you get?
8.
That's the other endpoint. So now let's do this problem. They're saying P1 is -3, 6, which is right there.
draw this.
And they're saying the midpoint is -1, 4. So that's the midpoint. So there's some line, and the other point is over here. Let's figure out what it is. What do we do on the x-coordinate to get from -3 to -1?
So we're actually going down at this time?
Correct. By how many? What's the difference between -3 and -1? If I drew a number line, -3, there's -1. What's the distance between those two? Still there? Did I lose audio? Or are you still there?
Hello?
Yeah, are you still there?
Yeah, so that'd be 1.
No. What's the distance between -3 and -1?
2.
Okay, and then keep going in the same direction by 2 more units down. In other words, if I've got to go 2 units to get to there, I want to go 2 more units in the same direction. That gets me to a +1.
Right.
Okay, now let's do the y-coordinate. How do I get from +6 to +4?
+6 to +4.
I get from there to there. What do I have to do?
So you go 2 more.
2 units down. The direction is very important because you have to keep going in the same direction. So what's the y-coordinate of this endpoint? In other words, starting from 4, keep going 2 more units down.
That'd be 6.
Is 2 down or 2 up from 4?
2.
There you go.
Because we're going down.
Yeah, and now notice if you were to check your answer, you would add that to that, divide by 2, you get that. Add that to that, divide by 2, and you get that. So you can always check your answer real easily by adding the 2 numbers and dividing by 2. In other words, if they give you the 2 endpoints, it's very easy to find the midpoint. If they give you 1 endpoint and a midpoint, slightly harder, but it's not really a tough problem. You just have to know how far you're going and in which direction. Notice that it wouldn't make sense if I put a 6 there. That would be impossible if you look at it visually. Because that puts it back up here, right? That puts the y-coordinate back up there. Well, you got to keep going in the same direction that you're going. And you go down when you go from 6 to 4. You're going down by 2, so I go down another 2, 4, and I get that.
Right.
All right. One last problem. Find all points on the x-axis that are 5 units from this point. Well, let's plot this point. Whenever I plot these, I don't ever take the time to grid it. It's a waste of time. I can approximate it. That's approximately 4, excuse me, I didn't approximate that very well. Here it is on this side of the So they want all points on the x-axis that are 5 units from that point. Well, first of all, let's talk about the definition of a circle. The definition of a circle is the locus of all points that are x amount of units from a center. So if I were to draw a circle about that point that had a radius of 5, that would be all points that were 5 units away from the point they gave us.
Right, okay.
What's the equation of that circle? Have you had conic sections at all?
I don't.
Well, the equation of a circle is x minus h quantity squared plus y minus k quantity squared equals the radius squared. That's the equation of any circle, and h and k are the center, and r is the radius. So if I want to take our circle here and translate it to a proper equation for this circle, I would say x minus 4, the x-coordinate, quantity squared, plus y minus 3, the y-coordinate, quantity squared, equals the radius, which I know to be 5. So there's the equation of my circle. But that's the equation of every point on the circumference of that circle. Will satisfy that equation. And their question is, find all the points on the x-axis. Well, there's only 2 points on the x-axis. And to solve for it, we need to solve this equation for x. Well, when you're solving this equation for x, you're going to take everything else and put it on the other side of the equation. So let's start with this. I'm going to move this to the other side. You with me?
5 minus, I'm just writing y minus 3 squared, okay?
Okay. And now,
so we leave x by itself.
We're trying to get it by itself. What's the next step in solving for x?
So now would we divide x?
No, remember what we did before? When we had x squared equals 16? Square root of both sides.
Square root.
That's the difference.
Get them by itself.
Okay,
So
well if I take the square root of the left, I get x minus 4. If I take the square root of the right, what do I get?
The square root of 25?
No, got to take the square root of the entire right side.
Oh, the entire right side.
And it has to begin with plus or minus.
Plus or minus square root of 25 minus x minus 3 squared.
Okay. Now isolate x.
We're going to be adding 4 on the other side. 4 plus 4 minus square root of 25 minus y minus 3 squared.
That's what x is equal to in my drawing. No matter where you're at on the circle. If you give me a y, I can tell you what the x coordinate is. Well, what is the y coordinate at those 2 points right there?
At which 2 points?
Points I've circled.
Would that be -3?
No. What's the y coordinate when we're on the x-axis? 0, by definition. Remember, this is the y-axis, this is the x-axis. Their question was, on the x-axis, find all the points on the x-axis that are 5 units away from that. Well, there's only 2 of them. There's this point here on the x-axis, and there's this point here. All the points on the circumference are 5 units away from this center. But there's only 2 of them on the x-axis. And the key is y equals 0 on both of those. Right?
Okay.
You see why y equals 0 at that point? Remember this. All x-intercepts, y equals 0. All y-intercepts, x equals 0. So to figure out...
Can you repeat that one more time?
Yeah, whenever you're asked about the x-intercept, you know one thing, y equals 0. When you're asked about y-intercepts, x is equal to 0.
Okay.
I mean, you see why? In other words, if I have a circle here, when I'm on the x-axis, what's the y-coordinate right there?
0.
Yeah. When I'm on the y-axis, what's the x-coordinate?
Oh, I see. Okay, 0.
That's an important thing to remember, because intercepts are very important to pre-calc. And you're going to be asked a lot about find your x-intercepts and also find your y-intercepts. So it's really useful to know that when they're asking about x-intercepts, y equals 0. So how do I figure out the x-intercepts here?
Well, we know that, well, does x equal 0 in this case?
No. Y equals 0.
Okay, so we know that y equals 0, so we solve for x.
Right. And I can do that by merely substituting 0 for y.
Because we know that that's what that would be.
The y has to be 0 when I'm on the x-axis. Okay? So now what are my 2 points? Well, I got 4 plus or minus. Well, this is the square root of 16, always. So, x equal 4 plus 4, and x equal 4 minus 4. So, the 2 points are 8 and 0. In other words, on my original drawing, where is it? This point is actually at x equals 0, and this point is x equal 8. Both of those points are exactly 5 units away from that circle, center.
Center, right.
Notice you even make a 3, 4, 5 triangle. That's the 3, that's the 4, that's 5. And I can go this way, same thing, it's a 3, 4, 5 triangle. Now, perhaps there was a different way he wanted you to do this problem. The way I did it utilized conics and the equation of a circle. He may have wanted you to do it using geometry and recognizing a 3, 4, 5 triangle. I don't know. There were multiple ways to do this problem. Personally,
But yeah, no, this is actually understood.
Personally, I like the way I did it, because the way I did it gives you the equation for all points on the circumference. And that's what the equation of a circle does give you, is all the points that are on the circumference of the circle.
Right. Makes sense.
All right. It's probably a good place to stop. We did a couple hours.
Yes, thank you very much.
You're welcome, and I am happy to continue working with you. Had a bit of confusion with some of the varsity tutor students as far as the next session goes. Some of them expected me to have a session 1 week later, and I didn't know it, so I didn't show up. Do you want to schedule something now, or do you want to just keep in communication with me through Varsity Tutor?
Yeah, that would be great, and then I'll see how I'm doing as far as this week goes.
Yeah.
My class is on Tuesday. I'll definitely keep in touch with you and let you know what exactly, even what I got on my take-home questions, just to see where I'm at.
Yeah, it might be worth reviewing then. If you get some of them wrong, you might want to go over them. So, but you will get a copy of today's session. Let's see. Let's make sure I have your email address. Hold on. maha.butte@gmail.com.
That's it.
I will send you, it won't be till tomorrow morning or later this evening, but it will be a link to where you can watch the recording of the session. And you'll be able to fast forward it if you need to, rewind it, or pause it.
Perfect.
Okay? All right. How do you pronounce your first name? Is it Maha or Maha?
It's just Maha.
Maha. Okay. Maha, I hope to work with you again, and if not, good luck.
Alrighty, thank you so much.
You're welcome. Bye-bye.